The next transformation is log transformation. So the primary purpose of this kind of transformation is when you have exponential growth. If the data values are growing at an exponential rate, to dampen that exponential rate and make it more amenable for simpler models is to take a logarithm of all those values. So you transform y into ln of y, natural logarithm, and we will call that L sub t. We'll use the notation L sub t to mean natural logarithm of the actual value. Remember, when we do that, to go back from the natural log to the actual value of y, all you have to do is to take the exp, e to the power. In Excel, that function is exp. So if you do exp of L sub t, that'll take you back to y sub t. So in other words, exp is the opposite, is the antidote for the logarithm. So if like multiplication is the antidote for division, exp is the antidote for natural logarithm. So now, if you take the first difference of these logarithms, like L sub t and L sub t minus 1, which is actually the same as the ratio. So dl sub t is, if you take the growth rate, not the growth, if you take the y value divided by the previous y sub y value, if you take the ratio, okay, and you take the ln of that ratio, so that is ln of y sub t minus ln of y sub t minus 1. So it's the first difference of the logarithms, okay, and use that as the data for which you have to forecast, and then your forecast for the future time period will be the latest actual value times, okay, so you need times the exp of dlt. So this can be done. Let's go to Excel and see how we set this up. Okay, so this will be ln of y sub t divided by y sub t minus 1. Okay, now you see this, that is the same as ln of y sub t minus ln of y sub t minus 1. They both are the same thing, so you don't need to do both. You do one, that's enough. So ln within brackets y sub t over y sub t minus 1. So now you copy that, and then you can do the forecasting based on this. And let's plot this and see how this transformation looks. Okay, add the x-axis values here going from 1964 to the end, and let's bring that graph down. Let me put it right here. So chart title is time series of first difference of ln. This is first difference of ln y. Okay, and the x-axis value is here, and the y-axis is ln of y sub t over y sub t minus 1. And once again, this transformation also works very well to dampen the trend and make it kind of stationary. And if you use this transformation, then our forecast is going to be, you take the actual value from 2009 and multiply by exp of the forecast of the difference in the first difference of logarithm. So these are the three transformations that we can consider, and remember, these transformations are for converting a time series with the trend back down to a stationary time series. So simpler models like moving average and exponential smoothing, we'll be discussing those models in the next chapter, that these models can be applied for computing forecasts. Okay, so here is how we can forecast from the transformations, okay, back into the original values. So let's assume that we're going to use random walk forecasting model, which means naive forecast. That is, whatever the previous value was, that's going to be our forecast for the next time period. Now, the procedure itself is independent of what model we use. Whatever model we use, we come up with a forecast for the transformation. And then we have to de-transform the transformed forecast back into the original value. So here, column B has the passengers, that's our y sub t. Then we have first difference, growth rate, and difference in log transformation. So those are the three models that we looked at. So if we use random walk model, then forecast for d sub t is the previous d sub t. So for 2010, forecast for d sub 2010 is the d of 2009. So that's the first difference. So that's our forecast for d. So now we need to convert that back to the original value so we can have a regular forecast, and that would be, you take the y sub t minus 1, see that one, plus our forecast. So then that's our forecast in the original values for y. So this will be forecast for y sub 2010. Now we can do the same thing again using random walk model, and remember, this is independent of what model we use. Whatever model we use, we come up with a forecast for the transformation. So here column E has the values for G sub t. So G sub 2009 is the forecast for G sub 2010. Okay. Then our forecast, bringing it back to the y values, will be, you take the previous y value, okay, times 1 plus forecast for G sub t over 100. That is, if G sub t is in percentages, then we have to convert it back to proportions, but we already have this as a value, not as a percentage, so there is no need to divide by 100. So 1 plus G sub t in regular values, and that gives you a forecast. This is using the growth transformation. So if you're using the logarithm of y sub t over y sub t minus 1, or log ln y sub t minus ln y sub t minus 1 transformation, then once again using the random walk model, that will be the forecast for dl sub 2010. Then the forecast is, you take y sub t, applying the d transformation, okay, times exp, so that's our antidote for logarithm, exp of that, okay, and that gives you, actually it gives you the same forecast as the previous one.